For that introduction. If any of you have actually heard Dr. Curtis speak, then I should probably run away now because he's an amazing speaker, and I don't know if I'm going to live up to that. But actually, Bill is a colleague of mine, and he has a long history in software engineering. He unfortunately had some knee issues, kind of an adverse reaction to a procedure that had been done on his knee, and so he lives in Fort Worth, Texas, and just couldn't quite make the trip up here. He was told to kind of stay off of it, and travel can be a little bit grueling. So he asked me to fill in. I've got his notes. I might refer to them once in a while so that I don't miss anything, but I know this topic pretty well. And the topic is all about measuring software. Now, Bill is a statistician, and so he likes to measure things. And I think some of you might be saying, how can you measure cybersecurity? And that's actually a tough problem. How can you measure software? Measuring software is something that has eluded us for a long time. And this is partly why this consortium was formed. So I'm going to tell you about it. I'm going to tell you what the approach is. What we're trying to do in the consortium, and how this adds up to an ability to actually measure the cybersecurity of software, as well as some other things about software that you may be interested in. So the Consortium for IT Software Quality was formed, I think, back in 2009. It was a joint kind of effort between the SEI. I think most of you should know the Software Engineering Institute at Carnegie Mellon. This is I also got a trick laptop. The software, is not working. Well, I won't say anything about the maker of this software based on where we are. But yes, this software has probably not been run through a CISQ measurement regime. So let me know next time that comes up. Yeah, so the SEI and the Object Management Group, OMG, I think some of you might know, who've done a lot, it's a standards organization, have done a lot of standards around things like CORBA, UML, and things like that. So, SEI is not primarily a standards organization, so they got together, and, SEI's got a lot of deep engineering expertise, and, OMG is a standards organization, and they kind of formed this consortium to really develop these standards about how you measure software. And then they asked, actually, Bill Curtis, Dr. Bill Curtis, my colleague, to head that up, as he was the gentleman that actually headed up the software process program at the SEI that introduced the capability maturity model to the world. So Bill is basically the guy that wrote the CMM and put that in play. And so now this is kind of his next act, so to speak. And actually, one of the things that he told me a number of times is one of the motivators for doing this was there were a number of systems integrators, Accenture, IBM, Capgemini, guys that do a lot of ADM, application development and maintenance work, that were coming to the SEI primarily and saying, look, it'd be great, because they all adopted CMM and level 5 and all that. We all know how that all kind of went in the 90s. And they went to SEI and said, we're seeing a lot of quality metrics, around software show up in our contracts. And it'd be great if, right now they're all different from all of our clients. It'd be nice to see if there's a standard that could be deployed so that we could all kind of, play to the same hymn sheet, so to speak, right? So anyway, so that's the formation of the consortium. Right now, this is the sponsors, the current sponsors of the consortium that you see up here. I work for CAST, one of the sponsors of the consortium. And actually, when they started, there were something like 25 companies that were involved in kind of defining the initial set of criteria that they want to measure. In fact, I guess that's how this works. All right, so this is what the metrics are, right? And this is what the 25 companies, they got together in kind of an executive forum in DC, Frankfurt, Bangalore, a bunch of companies that we all heard of, GM, FedEx, BMW, AXA, companies like that, right, that care about software quality. And they defined these kind of 4 quality characteristics plus actually a sizing characteristic, which is a function point. I'm sure if any of you have dealt in software for any extent of time, you've probably been exposed to function points at some point. Pretty hard to measure, manual process, and so a lot of folks that got together here said, hey, if this is about software measurement, then it'd be great if we could actually standardize a computable function point measure. And then you can divide defects or vulnerabilities per function point or whatever, and that could also be a basis of quality metrics, in addition to being able to measure reliability, performance efficiency, security, and maintainability. So that's what the original founders, companies that founded Consortium decided that they want to measure. And OMG has got a process for for running these standards out and creating them. And actually, the function point standard was standardized through OMG in 2013. February 2013 or something like that. And the other 4 characteristics, reliability, the software characteristics, they became an official OMG standard in around October, like a year ago, October of 2015, last year. And then there's a process that OMG has for moving standards into ISO. So I think the function point standard is moving through that process now. And then the other standards, reliability and performance efficiency, et cetera, security, are going into that process, I don't know, probably in a couple of years. I'm not sure exactly what the timing is on that. And when it comes to ISO, timing is a little bit challenging because they can be a little bit slow to get standards going. And I'll talk a little bit about ISO in a minute. So just a little bit more on the actual characteristics, what the CISQ community is calling structural quality characteristics, right? So we're talking here about the qualities, the kind of illities of software, right? The maintainability, and those types of illities. I can't think of any of the other illities off the top of my head, but there's a ton of them if you go on Wikipedia. So this is not functional quality. And so what specifically the charter of CISQ has been to really define these quality characteristics in a way that can actually be measured and can be computed and can be put into potentially a vendor contract. And this is something that I'll talk about in a little bit. So what you see is for each of these metrics, each of these characteristics, there's a set of essentially rules or violations that comprise that metric. And so for security, there are 22. And those of you that are familiar with software, specifically software security, probably know the common weakness enumeration that was funded by DHS. Actually, I just saw Joe Jarzenbeck out here. He was one of the kind of progenitors of this and working with the MITRE Corporation. And the common weakness enumeration, I mean, they enumerate something like 800 weaknesses, something like that, of software. And you can find that on the MITRE website. And so the folks, so it's basically a set of problems that you're looking for in the software that, could be in the security context, could be a vulnerability. In the, reliability or quality context, they could just be problems that cause a system to fall over. In the case of reliability, or problems that cause a system to be inefficient. In the case of performance efficiency, right? And then maintainability is something that I think we all probably understand. So that's basically, and then there's some examples here in terms of the types of issues, right, that you'd be looking for. So, exceptions, handling exceptions in the reliability standpoint. I mean, if security, and I have another slide here with more detail on security, but SQL injection, cross-site scripting, buffer overflow, these types of things. Some of them, by the way, bleed over between security and reliability. I think out of the 22 violations, there's something like 5 or 6 that are also in the reliability metric, and I'll talk about that in a minute as well. So, and then, you've got some examples, in terms of efficiency, loops tend to be, you might write a loop that calls something in another part of an application, and you don't realize that that call is actually really expensive, you know? And then if you cycle through that loop, you know, a large number of times, then that could cause an application to time out, or you can make the network or the CPU churn a lot more than you expected, and actually even your application might not go down, but because of the churn you're causing on a network, it might cause problems for some other application. And we've seen all sorts of things like that. So there are a lot of ways, especially when you get to a large legacy type of application, or even something new that you're writing that's calling legacy components, there are a lot of ways that you can cause inefficiency. And then maintainability, coupling, cohesion, dead code, and naming conventions, things like that. So these are the types of things, and for each of these, and you go on the CISQ website, for each of these characteristics, all of these are listed out. This is all public domain. You know, you can go there, you can download and see what those issues are, you know, and including for the security characteristics. So let me drill down on that. So this was, the security piece was developed with Bob Martin, who runs the CWE program at MITRE. You know, he's kind of one of the thought leaders in terms of application software security. And as I mentioned, it's taken out of, you know, this CWE repository. So there, you know, I think every couple of years, the SANS Institute, together with MITRE, they kind of define their top 25 violation or vulnerabilities or weaknesses, I guess, software weaknesses du jour or du year. Whatever that phrase might be. You know, and the challenge actually is with that, again, like if you're in the software industry and you're writing software, some of these things you can't really look for them or it's not easy to look for all of these vulnerabilities or weaknesses. Some of them are heavily manual. You have to just you know, you have to scan the code. You have to sit down with your security experts and, you know, and actually look for these problems. And so what Bob and the team did is actually identified the 22 vulnerabilities or weaknesses that you can actually look for using static analysis, you know, using automated analysis, so, you know, so that you can get a repeatable result. You can look through a bigger application set, you know, more quickly, et cetera. And so this top 22 list, so to speak, is what made it into the CISQ measure. And, you know, and you can see, I don't know if this is the whole list. Again, this is Bill's slide, so I didn't quite count, but this looks like about 22, right? So I think this is pretty much the whole list, and you can see what these are. And, you know, it gives you a sense of, you know, what types of issues, you know, CISQ is defining as part of some of the other software characteristics as well. It's, you know, these types of things. So, you know, and of course you see the kind of perennial favorites like, you know, the SQL injection, cross-site scripting, and memory management issues that come up that, you know, can cause an application to break or be breakable. So these are the actual security measures. Now, a bit about ISO. I said that I would mention that. To the extent possible, you know, CISQ is trying to align its standards to other existing material out there. Some of you might be familiar with ISO 9126, which was a software quality standard out of ISO from, I don't know, 10, 15 years ago. I mean, it's been around for a long time. So the ISO folks have now refashioned that standard into this set of ISO 25000 standards. Which, you know, is kind of close to the 27,000 that, you know, we all see in the security space. So that's replacing 9126. And so 25010 it defines these quality characteristics that, you know, that ISO believes need to be measured or, you know, considered as a software quality standard. The problem with ISO, if any of you have actually looked at the ISO standards, I know it's a fascinating read. I recommend it, you know, to everybody. Good for a Saturday night. The problem with the ISO standards, and I've looked at them in more depth because it's something obviously that's of interest to me, is that they tell you what you should measure, but they don't tell you how. right? So they tell you that, you should measure operability or functional suitability or reliability, right? And they define what that is. So at least you have it. I mean, it's useful. It's a framework. These are the things that we should measure or should look at. But to me, that falls a little bit short of a standard because it's not something that you can really put a yardstick against, right? And you can't score someone on this ISO scale. You can't say that, well, you've passed, you've been certified against this ISO standard. So it kind of falls short of that. Now, Bill, if he were here, he would tell you that he's actually he's one of the two US representatives to the ISO committee on the 25,000 standards. And actually, there's a fairly large, it's pretty international. There's a large, I think, contingent out of Japan, which I guess should be no surprise if you're talking about quality, that is helping define the standard. And a bunch of Europeans actually, in terms of these, by the way, I've worked now a lot with Europe, at least. My observation for sure is that in terms of these types of standards, like software quality, in Europe, somehow the folks there, the software engineering community, takes this stuff a lot more seriously than we do here in the US. It's just blatantly obvious. And you talk to folks about software quality, even I don't know what you guys think of Gartner analysts. I talk to a lot of those folks as well. The analysts that are based in Europe, they know what 9126 is. They know what 25010 is. The folks in the US, it's kind of hit or miss. Quality, that's like, does the software do what it's supposed to do, right? That's what quality is. And
why do you think that difference is there?
why? Well, that's an interesting question, and I think it's cultural, actually. I think cultural. I think that the engineering discipline in Europe is a lot more developed, I think, than here, in the sense that the folks that go into software development in Europe, they tend to more often have training in software engineering. People kind of train for their profession and they stay with their profession. I think it's more common here, for people to, go into IT or go into software development without necessarily having software engineering training, right? So that's my observation. You can throw a tomato at me if you want. But that's kind of what I'm seeing. But yeah, that's probably a deeper, more interesting question to.
Do you think that the educational programs, universities in Europe tend to offer coursework in metrics, quality metrics, and security metrics versus in the U.S. where you?
I think the graduate. Yeah. So the question is, do the education programs in Europe offer coursework on metrics and quality? They do. Yeah, they do. I think that tends to be more of a graduate level offering, and not all universities, but you see that more often than here. Absolutely. And just I think the approach to engineering, I think in Europe tends to be a little more kind of rigorous when it comes to software. It's funny, in the kind of software quality space that CAST works in. A lot of the firms that work on software quality issues and static analysis come out of Europe. So that's just another observation as well. Yeah. What's in Germany? Yeah. Yeah. No, it's just I think it's a mindset thing. And it's funny. I remember I was at a conference in the UK. Where and I think the UK is a little more aligned with the US in this regard, on this issue. And there was a gentleman who ran. He was a CIO at Deutsche Bank for Deutsche Bank investment banking, and in the UK. So the investment banking for Deutsche Bank is run out of US and UK. It's not a German thing at all, even though it's called Deutsche Bank. But and he was saying that he did have some developers in Germany, and he was saying that the developers in the UK, like what we value in our developers in the business, is that they understand the functional domain, they understand the business. We don't value so much software engineering skills in the UK, but in Europe, it's a little bit more shifted towards the engineering skills. Sir?
infer correctly that this metric says that the absence of weakness equates to quality?
The absence of weakness. So you're saying, do I infer correctly that the absence of weakness equals quality?
Is the absence of weakness?
Essentially, yes. I mean, that's what this metric is set up to do, is to look for well-known weaknesses, engineering weaknesses that are known to cause problems.
So I could have an airplane that didn't have any weaknesses but couldn't get off the ground.
So absolutely, that's right. So you could have an airplane, and so the point, and I think the point that the gentleman is making is functional quality versus the structural quality, right? So you could have an airplane that's rock solid, structurally sound, but it's not functionally, capable of doing what the function's supposed to do. And I think in the software world, the analog would be, you can have a great piece of software that's really well designed, really well engineered, but it's not doing what the user wanted it to do, right? So absolutely, and that's kind of the balance between the functional focus and the structural focus, and that's kind of what we're talking about. I think there's a lot of functional focus when you think of quality, and it's important, of course, but there's not so much structural focus often, and I think that's changing. We're
assumption that there should be a balance somewhere, or at least determine what that balance should be.
Well, so yeah, there should perhaps be a balance, and there should be a conversation about it, and there should be a way to make trade-offs about how much structural quality do you have and how much do you need, right? So, for instance, in the area of security, with security weaknesses, you should be able to specify, right? I don't want any weaknesses of this type in my software, or I'm okay with having some kind of a weakness density that's lower than whatever 0.1 weaknesses per function points or something like that, right? So you should be able to have an intelligent conversation about what's going on structurally within your software, because that's the stuff that you don't see, right? That's the stuff you don't see. That's the stuff that blows up on you, the stuff that causes the network to churn, or opens holes for hackers to get in, right? The functional stuff you see, and that's what the whole conversation's about today. Not the whole conversation, but a lot of it.
US, UK.
Especially in the US, UK, yeah, over here. So back to the ISO discussion. Sorry, I kind of veered off on that tangent, but it's an interesting one. So what CISQ has done is it's taken 4 out of the 8 25010 characteristics and added the dimension of, so you've got reliability, you've got security, maintainability, and performance efficiency. So we know that these are structural quality characteristics that we care about, and what CISQ has added is here's how. Here's how they should be actually measured, how they should be looked at. And again, it's not perfect. I'm sure that the standard is going to evolve. It evolves through a community process that's managed by Object Management Group. But the first iteration is there, and at least now there's some sort of benchmark or some sort of yardstick that you can use to say that this is, we consider this to be software of high reliability or good security or not, right? Yeah.
How does this compare to Six Sigma?
How does this compare to Six Sigma? So Six Sigma is more of a process methodology, right? And so this is something that could be used in a Six Sigma environment, right? So Six Sigma is looking at, what your process, how your process is working, and the extent to which your process is delivering quality output. So in the Six Sigma context, you might, you're looking at your output, right, and you're seeing where you're deviating from your kind of Six Sigma goals, right, of quality standards, and then you're trying to see where in the process you need to tweak things in order to get within the tolerance, right? But in order to deploy something like Six Sigma, you need a measure of quality that you can use to see the output, so that you can then apply this kind of Six Sigma thinking to walking back the cat to see where, where the issues are, right, where the process issues are. So this is that measure of quality that you could apply in a Six Sigma context. In fact, one of the things that's been challenging is to actually turn this into a metric, right? So here, what's defined by CISQ is what are the things that you need to look at, and the way that so far that's been proposed to turn it into metric is to look at densities. Density like per 1,000 lines of code or per function point of how many of these issues that have been defined by the standard you have, right? And so one of the ways that Bill is proposing now to turn that into a metric is in a sigma metric. Because for any of these rules, let's say something about, I'm just going to go back to, improper input neutralization, number 79, CW 79 here, cross-site scripting. So input neutralization. So for that rule, for any given application that you look at, you're going to have X number of opportunities to either get that right or to get that wrong, okay? And so out of that X number of opportunities, that's like X widgets coming off the conveyor belt, right, the manufacturing. So for that X number of opportunities, how many did you get right and how many did you get wrong, right? And you can apply to that, because then it turns these opportunities into widgets, right? It's hard to turn software into Six Sigma widgets, right? But then you're kind of turning those opportunities into the widgets, and you can apply a Six Sigma metric to that. And actually, if you do apply that, the best software in the world is going to be 3 Sigma or so, at best. I mean, 6 Sigma for software in terms of, opportunities to get these metrics right is almost an unattainable goal. I mean, most legacy software that we see out there has a lot of these weaknesses in them, in that software. And so, like, the best world-class software, top shelf, is going to be about 3 Sigma or so. But anyway, that's a little bit of a, kind of going off in the weeds there. But so to answer your question, in terms of Six Sigma, this would be the measurement, the quality measurement that you'd use kind of at the end of the process, or midway through the process, to see where you have some process flaws that you need to fix, so that you can measure better quality and tighten your tolerances. So in a way, that's basically the way I would think about it. So so CISQ is supplementing the 25023 with the actual source code level metrics, and actually, from what I understand, in the ISO process, where this is going to go is it's going to go into that 25023 standard, as the the technical appendix to the to these 4 out of these 8 ISO standards, right? So that's the ISO fast track that I talked about before. That's probably where that's going to go. All right. So now another thing, just to talk a little bit about the types of applications that we're dealing with. Now there are a lot of types of software out there. There's device software. There's IoT software. There's scientific software. So the software that we've been looking at the most, actually, with CISQ, because it's the Consortium for IT Software Quality, right, has been IT software. So software that handles information, right, data, information technology, transactions, things like that. So when you look at IT software, it's actually a pretty complex beast, right? Because typically you've got big software systems, lots of components to these systems, and you've got development teams. You've got some guys that are coding in Java, some guys that are writing .NET, some guys that are writing in COBOL. You've got the DBAs that are managing the stored procedures and the database structure. And actually, I'm not sure if I don't know if I'm going to use this build very much, but basically, just to kind of get the whole slide on there, I don't like builds. So this is what a typical mission-critical IT application looks like, right? You've got You got your interfaces, you've got some stuff sitting on the cloud maybe, or a mobile interface, or the web interfaces, right? And then you've got some web services in the middle potentially, right? XML, enterprise Java or some .NET framework. And then, well, with Java, you've got all these open source frameworks like Struts and Spring and Hibernate and all that stuff. And then all of this eventually gets down to the database, to Oracle or DB2 or whatever, right? And actually, an average application, we do a lot of research on IT applications. The average application actually in our benchmark repository is something like 600,000 lines of code. And that will have, probably about 1,000 tables and maybe 800 to 1,000 stored procedures. These are the types of applications that handle information today. Now, maybe with blockchain and all that, that's going to change at some point. So the architecture is going to change potentially. But, that's a little ways coming. And, this is like what IT software looks like. So the point here is that when you're analyzing that software for security issues, or efficiency issues or reliability issues, you need to look at it not just, and especially when you're doing static analysis, or it doesn't matter whether you're using a tool for static analysis or you're, doing manual, code review, you need to know how all of these components of the application actually interact and how they play together. And rarely is there somebody in the organization who knows how all of this ties together. And if that person is there, everybody knows who they are. It's kind of like the secret velvet carpet thing, and and everybody knows you got to go to Bob, and he really, like if you can't figure it out, just go to Bob, and then he'll tell you, what database objects are used, which ones shouldn't be used, don't touch this, use that, and I've seen this many times. So to actually do real information security analysis on an IT piece of software is a pretty complex undertaking. And this is one of the things that CISQ has developed some material around, and how you actually need to look at things at the unit level, but then also at the single technology level, and then at the system level as well. Looking at things kind of across layers, you get to see things where, I don't know, like if you have an input validation method, right, that's making sure that anything that's going into, from one of the interfaces, from a mobile app or from a website, that input validation method is actually used for everything that actually touches data that contains PII, right? So, this is the kind of thing that you need to be looking for. Or conversely, actually, if you have an input validation method, then you don't need to throw a whole bunch of false positives about, some object that doesn't have input validation, because it's going through that input validation method anyway, so it's not a problem, right? So these are the types of things that you need to look at, and it's filtering, authentication, and access types of issues that you need to look at a system level, right? So this is, and there's some material on this, on the CISQ site, but this is an important issue, for CISQ to or at least in some of the CISQ language and material, you'll see that they actually split out issues at a unit level and at a system level, right? And for security specifically, you want to be looking at things obviously at a system level, because at a unit level you'll get a lot of false positives and you get a lot of false negatives essentially. So that's the problem with modern applications. And I don't know about all of you, if you get to write purely greenfield projects and software, I don't know, most of the projects that I've been on myself, I'm an IT guy by background, as you can probably tell, we're not greenfield, or there's some greenfield component, but there's always some interface, something that's legacy, and you just have to live with that. I mean, that's why you're part of a bigger firm, because you've got all of that legacy stuff that runs the current business processes that you're augmenting with whatever you're doing. Anyway, so that's that. Now, just a quick word about, and I mentioned this a little bit before, about security, reliability, that they're related. I can't remember exactly the number, and you'll see this on the site if you look at it, but something like 5 or 6 of the weaknesses that you look for in security in that top 22 CWE list are also in the reliability metric for CISQ. And it makes sense, right? Because things like memory management, for instance, right? Buffer overflows. You can have a buffer overflow that will crash your system. That's a reliability issue. Or a buffer overflow is something that a hacker can take advantage of, right? In order to break into your system. So, there are things like that that are really obvious, that are clearly an overlap. And of course, actually SEI, Carol Woody, Dr. Woody at SEI, and a number of others have done some research on this. We at CAST, we've done some research on this as well with our benchmark repository, and you see this actually bear out in the research. So the data actually shows that there's a pretty strong correlation, something like a 0.4 or some, 0.4, 0.5 correlation between, reliability and security. And I guess I see some heads nodding in the room. I guess that doesn't surprise anybody. But it's funny because we have a separate conversation about software security and software quality, quality security. And it's funny, that's another topic where we can get into a big semantic debate. Is quality part of security? Is security part of quality? Are they two separate things? There are probably a number of points of view on that in this room. I've been in a number of these debates myself that actually can tickle me a little bit, but in the end there is an overlap, and that's why it's not clear, and it does make sense when you're looking at your measurements, when you're looking at your process, to look at reliability issues. And this is where the tie-in is. It's really with reliability. Performance efficiency is a completely different thing, and that's, by the way, the data bears that out as well. It's completely uncorrelated to reliability and security. But if you're looking at your site reliability or application reliability and security, you should be getting some synergies out of that, right? You should be looking at that together. And that's what the research says as well. And I guess it probably makes sense to everybody. And I'm sure this isn't a big surprising fact. But and actually, if anyone's interested in these research studies, I don't know if they're on the CISQ website, but I know I've seen they've been presented at other CISQ forums, and so I know that if you're interested, let me know, and I can help you find them.
What did you say was uncorrelated?
Oh, performance efficiency.
Okay.
Yeah, so performance efficiency, very different thing, very different kind of set of metrics, that you're looking for how the application's behaving and using, network and CPU resources. There's a little correlation in there, but it's not anything noticeable. So it seems like it's a different vector. And the other thing I just wanted to say is that of the 4 CISQ quality characteristics, the security one is by far the most challenging to measure and to get at. Those 22 rules that are identified by the CWE folks, they're really hard to analyze for. And I work for a company that does static, basically analysis, and we struggle with some of these rules ourselves. It's hard. It's not easy. It's something that's continuing to improve. But and then of course you need to add dynamic analysis and fuzz testing and and instrumentation, looking at that at these issues. So that's definitely a tough one. All right, I just want to say a couple of words about the part of the genesis of this consortium, right? As I mentioned before, is that a number of systems integrators were interested in having a common metric, right? And actually, a number of CIO organizations have been quite interested in CISQ for, having a standard metric by which to measure software quality. And actually to measure productivity as well, because the function point's been around for a couple of years now. Well, the CISQ defined function point's been around since 1979, but this sort of CISQ computable function point's been around since 2013. So just kind of coming back to that, there's been a big interest in the CISQ community about how do you actually measure, put these standards into play in paper. In contracts with your software providers, right, and services providers. And so there's some, and what I did, I actually pulled the table out of one of the documents that's posted on the CISQ website it was written by a couple guys that, have a lot of experience, I think out of IBM actually, who are no longer at IBM, who have a lot of experience writing contracts, actually on both sides of the table or what have you. And actually, and some folks from ISG, I think, looked at this as well, which is the, sourcing advisory. And so, they came up with some suggestions of how you put these metrics in an SLA. And as I mentioned before, basically what they're using is densities, right? So, and I think this is based on function points, so 0.02, so the baseline, and I think this is a sample SLA, so you might look at an application and find that the baseline of unit level and system level are both 0.02 per function point, so findings per function point, right? Or weaknesses that have been found. Like in a typical SLA, you assign a weight to those issues, to that factor, and then you have a target, right? You want to get to a low of actually 0 for system-level security violations, and then there's a target number for the unit level. And then I think the only one that's 0 on here, the target that they defined as 0, is the system-level security violations. And there's an annual improvement target, and then you kind of add that up to, this is an overweighted SLA, it's called overweighted, it adds up to 200%, so the vendor could actually get penalized 2x the the at-risk amount. So anyway, so that's an example of how you put this in a contract, which makes it more actionable, especially if a lot of your development is being done outsourced. So that's basically it, and then I think that's it. That's what I had to talk to you about. So basically, the goal is to let you know what CISQ is doing, what the community is doing around software measurement, around security measurement, making security a little bit more measurable, and how you can get involved. Actually, CISQ, you can become a member of CISQ. It's free. You just go on the website, you sign up. Become a member. Now, if your organization wants to be a sponsor organization, then you can actually get involved in, some of the content and, the standards, and kind of pushing the direction that the standards are going in next. Actually, I think, so CISQ, they just almost finished another version of a function point, like it's enhancement function point standard. So, how you actually measure enhancements, not just how many function points do you have, but how many are you producing, adding, removing as you go along. So I think they just finished that. They're working on a technical debt standard. So how do you actually measure technical debt in software, of which, because of these 4 characteristics, you'll be able to split that out into security debt, reliability debt, et cetera, et cetera. So I think it's going in for a review in the December. So the question was, how close is that to being finished? The technical debt standard, I assume. I think it's going in for a architecture board review with the OMG in December, which means that they'll review it, and then there'll be another comment period after that. Well, if they don't like it, then it has to go back. And they have quarterly meetings, so then it gets pushed back to March. If they like it, then I think they say, all right, this is what we propose as the OMG standard, and then I think there's some kind of comment period, and then people can weigh in and add more thought to it.
I mean, that's very exciting because the ability to quantify technical debt beyond I feel bad
Yeah.
is going to be a big thing.
Yeah, absolutely. Technical debt has a lot of, I mean, a lot of folks are talking about technical debt, and I've seen people, I don't know if you guys hear discussions about security debt as well, but like how much do I have to fix in this application to make it secure, right? That's my security debt. And technical debt more broadly. Yeah, it's a great way to talk to the business about, we just didn't do a good job here, or maybe we're moving too fast, or we're not paying enough attention to, these kind of structural issues. And I think it resonates. So I think it's very exciting, I agree, that there would be a standard way to measure technical debt. So if you want to get involved, it's an open forum, and anybody can weigh in. So that's those are a couple of the initiatives that are going on in CISQ right now, and I'm not sure what's coming next after that. I think there's, and this is what like the sponsors we get together. I'm on the board as one of the sponsors. Accenture, Cognizant, Synopsys is out here. They have a booth, and a couple of Huawei, I think, a couple of other companies. I don't remember all of us, but we get together twice a year on the board and we talk about what are the next things that we're going to pursue. So that's coming up in a couple of months, and we'll probably have an update on what comes after the technical debt work. But that's been taking up a lot of cycles, obviously. So that's it. Hopefully I've done this talk some justice. Sorry that Bill couldn't be here, and we have questions.
So I could understand how this quality measurement would work in, you showed in the stack and you showed, well-known languages, well-known technologies and so forth. How do you in CISQ address new technologies that appear to be taking up market share, that robotics, for example?
Yep.
The scripting languages for those things.
Yep.
What are you thinking about that from your CISQ perspective?
Yeah, so the question is, how is CISQ addressing new technologies that are coming online, for instance, robotics or scripting languages of various sorts?
Have a substantial debt.
You could, we're already developing the debt on these pieces of software. That's a very good question. So up till now, just being honest about it, up till now we've been focused on the mainstream technologies, right? So the Java, .NET, COBOL, pretty much that trifecta. I think there's, and there's definitions around how you apply these metrics specifically to those technologies. So some of that, so CISQ is getting implemented by vendors, right? In the end, a standard is only as good as when vendors implement it. CAST is implementing, Synopsys is implementing. There are a couple of other vendors that are looking to implement as well. And so I think that right now where that conversation is at is, should CISQ take up a firm definition, technology by technology, which kind of multiplies the number of things that you have to define it's really quite significant.
Or one of your vendors.
Or do the vendors do
to
the
specialize?
exactly?
One of the things we just ran into as people move with RPA, they move from pilots to things which get more complicated. That moves up the risk thresholds ladder.
Right.
And in our secure SDLC, as you move up there, you need to have, white box, black box, etc. And for some of these new technologies, the question comes, how do I do that?
Yeah.
Or I can't do that. Now, is the straight answer no can do, no can code? Or is the answer, we have a risk to accept, and which vendor can help us to address that?
Right, right. No, that's a very good point. Very good point. And I think right now, and I guess I see the organizers coming back in, so I'm going to get the gong. But just to answer that question, I think right now the thinking is that the technology by technology stack is going to be addressed more by the vendor community than by CISQ itself. But I think as this process gets more mature, at the very least, it's a collaboration forum. To kind of bring together what are the rules and constraints you want to put on specific technologies that are aligned to these metrics.
But you might be a good place to join, post the question, and the vendors who want to hit on it will hit on it.
Absolutely.
Excellent.
Absolutely.
Okay.
Post the question, and you'll get a response. Thank you, guys. Thank you, everybody.